Welcome back. Glad you could make it. We got a little bit of a long one today, so I'm just going to dive right in. To the moon. Where are we now? Well, we have a pretty detailed international plan called Artemis, but more about that later on, with many portions and parts divvied out to various space agencies and companies. Some of these parts are in early planning stages and some are in development, while some others still are near final preparation stages. What do we know about the moon? We have about 572 kilograms of lunar samples on Earth right now, roughly 190 of which is from meteorites that have been found scattered around the globe. More samples are being collected as I'm making this video by the Chang'e 5 probe. These samples largely have distinctive iron and magnesium ratio coupled with a specific radiation signature. Based on these samples and all the data collected during and since the Apollo era, we know what elements are available and what our chances of finding a given element in a given area are. We know we can find hydrogen, helium, oxygen, magnesium, aluminum, silicon, phosphorus, potassium, calcium, titanium, iron, thorium, and uranium, and many more elements. Many of these elements are locked up in various chemicals, compounds, and minerals like water and orthosite, plagioclase, feldspar, albite, olivine, and ilmenite. We know that lighter elements are more common and heavier ones much less so. For instance, thorium, a relatively heavy element, can be found in concentrations of up to about 12 parts per million on the light side, scattered around numerous impact sites, while on the dark side it is only largely about 1 part per million. We know that some elements, like aluminum, are more common in terre or highland areas, roughly 3 times in this case, while elements like iron and titanium are more common in the mare or seas areas, 3 times and 5 times respectively. We also know that the moon is 238,900 miles or 384,400 kilometers away. We know that it's 2,158.8 miles in diameter or 3,474.2 kilometers. We know that it is approximately 60% of the density of Earth and has a specific gravity of 1.62 meters a second squared, 1/6 of Earth's 9.807 meters a second squared, or 0.1654 Gs, roughly 16% of Earth's 1 G, along with a few other critical data points, like higher cosmic radiation levels, even more than we get on the ISS. This is due to being further from the Earth and in a weaker area of its protective magnetosphere. Also, the moon has no atmosphere. Any atmosphere adds additional radio protection. Composition, thickness, and density are big factors here, but mean nothing to us right now because we don't have one to factor in. Don't freak out here. There are a few things we can do to protect our equipment and personnel. Besides, honestly, the fine particle abrasive dust might be a bigger problem in the short term. What don't we know? We don't really know how difficult it will be to extract usable quantities of these elements. We don't know exactly how known processes like the ones we use here on Earth will work in lunar environments. We have lots of unproven theories. On-site testing and prototyping is needed. Lots of it. We don't know what effect the lunar gravity of the moon will have on life we send there, most critically mammalian life, mice, monkeys, marmosets, and man, or women. We have a fair idea of what effect microgravity has long term, which I suspect is why we see International Space Station missions more typically lasting about 6 months. Though a few astronauts have been there substantially longer, we mostly stay near or less than 6 months. How? Well, this may be a one-word question. However, the answer is not nearly so short and sweet. From 1958 to 2020, we have launched hundreds of missions that at the very least flew by the moon. Some crashed, some landed, some entered into some sort of orbit, and some were even manned. See the Apollo program. With a healthy mix of successes and failures, which we still learned a great deal from, and even some currently operational ones like NASA's LRO, Lunar Reconnaissance Orbiter, launched in 2009, and China's Chang'e missions. One of these, Chang'e 3, launched in 2013, and Chang'e 5 T1 in 2014. And most recently, Chang'e 5, which touched down on the lunar surface on November 27, 2020, which plans to return fresh samples to Earth by the end of the year. There are 24 more lunar missions planned and at least partially funded and in development over the next 5 years, not counting 4 crewed missions. Some will run into delays, development, funding, political, or other, and more will be added to this list. For instance, 16 proposed robotic and crewed missions which still need funding. Additionally, there are 9 canceled or postponed missions going back as far as 2004. Some of these 9 merged into other missions, others replaced by different missions, and some may yet still see the light of a lunar day. If you want more details on this exhaustive list, I have provided a link to the wiki below. The biggest, most elaborate how is much more than a mission. It is a series of multinational missions, or rather, an entire program, on a comparable scale to the International Space Station. We will now start talking about Artemis. What is Artemis? Brief funding and development background. Some portions are revamped from the Constellation program, most of which was redirected into developing the SLS program that will be at least partially relied on. The name. As it turns out, Apollo had a twin sister, Artemis. I'm not going to dive into more on who she was for now. Plenty of information about her can be found using your favorite search engine. Artemis has 3 main legs or parts, and we will take a brief look at each of these. Much of the design relies on SLS, and currently we don't have a working alternative for it. We will lay out the program centered around it, even though we don't have a working SLS. But this is planned to change in late 2021. Feel free to fact check that. When it hopefully has its first launch, primarily to further certify the Orion capsule, but I digress. And besides, by this time, Starship may have put a Cybertruck into space, because that sounds like a great follow-up to the Roadster Falcon Heavy launched a few years back. Squirrel! Ooh, shiny! The 3 main portions are the Lunar Gateway, the Orion spacecraft, and LLS, or Lunar Landing System. Let's start with Orion. Orion is a crewed capsule, or more precisely, kind of an Apollo 2.0. Its primary purpose will be to ferry crew, cargo, and experiments to lunar orbit, whether to the Gateway or to rendezvous with LSS. It is designed to ferry and dock or berth with other craft rather than land or launch from the lunar surface. Capsule with service module, or trunk, weighs approximately 25 tons. If docked with the ISS or in lunar orbit, it can stay on its own power for up to 6 months. I suspect this time limit may have to do with battery, atmosphere, propellant related, even though it has its own solar panels, or it could have something to do with the 6-month typical mission we talked about a few minutes ago. We will have to look into this further and do a follow-up. There's also a deep space hab, but not sure if this has been developed or transitioned into the Lunar Gateway. The capsule section has 6 seats, but will probably rarely carry that many passengers. 4 on a lunar mission is planned. It measures a little over 5 meters across, and the Apollo capsule was a little under 4 meters across, and could only carry up to 4 crew members. This thing is quite diverse and capable. It is meant to be NASA's replacement to the shuttle program. I will probably do a follow-up video focused just on this. The capsule is built by Lockheed Martin with NASA, and the service module built by Airbus with the European Space Agency. On to the Lunar Gateway, formerly called the Deep Space Gateway, also referred to as LOP-TAC-G. Lunar Orbital Platform Gateway. Basically, this is almost a whole program in and of itself. It is probably the most complex and expensive part of early stages of the Artemis program. This is the primary international collaboration portion of the program, and so far it is planned and will be built in very similar fashion to the International Space Station, though current planning is for short-term crew occupancy and will be considerably smaller than the ISS. Though it is modular, it could someday outgrow the ISS. Early plans have modules being built by many space agencies. However, Roscosmos and CNSA are currently not invited or have other plans. The current plans are fairly loose, and we don't know what NASA funding will look like in the coming years just yet. As NASA, as usual, will be carrying a hefty portion of the financial burden, and we don't know how much impact COVID will have on space programs over the next couple years. I think the timeline will face some adjustments, but by the early 2030s, we will be at about the same current projected goals. A bigger question is how much those goals will change. As we near the end of the planned life expectancy of the International Space Station, I hope we build Gateway and other stations which are in operation prior to decommissioning the International Space Station. The ISS has been instrumental to science and technology efforts for 20 years now and has fostered a great deal of political cooperation to boot. Back at the end of the first space race in the early 1970s, few could have envisioned what the last decade has seen from the space industry. America reliant on Russia to get astronauts into space for a decade? What have you been smoking? And why hasn't it been taken away from you? At best, we might start to see some modules in orbit sometime in 2022. It will be in a near rectilinear orbit, or an oval polar type orbit. Its closest point to the Moon will be 932 miles, or 1,499.91 kilometers above the North Lunar Pole, and its furthest point will be 43,495 miles, or 69,998.5 kilometers below the Moon's southern pole. On to LLS, or Lunar Landing System. Last April 2020, NASA announced the 3 finalists in a competition for contract. NASA went about this competition a little different than most of their historical methods. Rather than a long list of specific requirements, they simply provided a short list of required capabilities. So many crew members, a certain cargo capacity, land on and launch from the lunar surface, maybe a 2-week mission time minimum. 2 weeks of daylight is typical on the Moon, with some situational variation at the poles. All 3 finalist proposals were very different from each other. Basically, NASA said, we want a more refined and developed plan from these 3, and here's some money to develop them further. First, we have SpaceX with its massively overcapable Starship LLM version. They were given $135 million, and SpaceX will focus on cryogenic seals and refueling in space with that money. I'm not going to go into Starship further on this, as that's a whole can of worms. And we'll probably do plenty of follow-up videos with Starship. Next, we have Dynetics. And if I have this right, they are owned by Lighthouse/Sierra Nevada. Numerous subcontractors will help develop their Alpaca design. This one is my favorite of the 3, as SpaceX will build theirs anyway, and I will discuss the third contender in a minute. Dynetics was given $253 million for further development. It just looks cool. A horizontal cylinder with a vertical rocket engine on each side. It is almost fully reusable. It leaves lunar orbit with 4 fuel tanks that it uses half of in landing. It drops the 2 empty tanks, which could later be retrieved and reused, but for now they are the only part that is not being reused. One version even has an underslung crew rover. Now, talk about off-roading. It also has 2 vertical solar panels. This will help generate enough power while landing near the poles. Most landings planned by Artemis will be near the southern pole. It will take SLS or Starship to get it to the Moon in one piece. It could also be launched in a couple pieces on a Vulcan rocket or similar and be assembled in space. Third, we have the national team led by a Blue Origin. along with Lockheed Martin, Northrop Grumman, and Draper. They were given $579 million to further their design, almost 1.5 times what the other two were given combined. The design is based largely on the Apollo lander, meaning it has many similarities. Blue Origin will build the descent stage. Northrop Grumman will build crew or space tug module derived from the Cygnus International Space Station module. Lockheed Martin will build the Ascent HAB module, and Draper will deal with guidance and navigation systems, collectively called the Integrated Lander Vehicle, ILV. This phase of the competition will be concluded in February of 2021. NASA will likely eliminate one design, maybe two. They will pick one or more designs and award further funding. See NASA's press release linked below for a bit more information. There are numerous other smaller projects involved, some already in use, some in final stages of building. Lots of lunar surface infrastructure options are on the table, and we don't know what ones will see development or implementation. Use of in situ or on-site resources is carrying heavy weight in almost all the proposals I was able to find while researching this video. Now, how does this help us do anything on or with Mars? Bottom line is, the more capable we are of doing things on the Moon, the lower the shipping and the logistic cost of getting assets to Mars. In addition, all this becomes applicable R&D for use on Mars. Knowing how to build equipment for working on the Moon is largely applicable to building equipment for working on Mars. A bulldozer that works and can be built on the Moon would need very little, if any, modification to work or be built on Mars. Though going to the Moon first is not critical to going to Mars, it makes good logical sense. A little cheaper, a lot faster to get there, and thus designs can have much faster reiteration and testing. Thank you for joining me. It is much more fun when you are here. I would love to hear your thoughts in the comments below, and as always, be sure your loved ones know what they mean to you. I hope to see you next time. Over and out.